If you want to solve this equation where greatest integer function is involved, you have to keep in your mind that this is an integer, this is also an integer, isn't it? Now, for these integers, for this integer, both sides will be one integer only. So, this you assume x by 19 modulo x by 20 modulo equal to n. This you have assumed n is an integer. N belongs to the set of positive integers. Okay? Because the question is to find the number of positive integral solution. Now you know that x by 19 when it is equal to n, what does this imply? That x by 19 itself is greater than equal to n, less than n plus 1. What does this imply? Because this is an integer, no? This gives n. So in which interval it will lie? It will lie in the interval n to n plus 1. N it can accept, n plus 1 it can never, because then it will exceed n. So this implies it's greater than equal to 19n less than 19n plus 1. This is your number 1. Now, x by 20, this is also n. What does this imply? That x by 20 will be greater than equal to n, less than n plus 1. This implies x greater than equal to 20n, less than 20 into n plus 1. Isn't it? It's alright, because this is the property of greatest integer function. So you have to get the value of x which lies in between these two and x which lies in between these two. So how to proceed? You will be taking those points on the number line. 19n, it is here. It is less than 20n, of course. And what about this thing? 20n and 19n plus 1? Are you confused? 20n, it starts from where? It starts from n equal to 1. If you take n equal to 2, then it is going to be 57, but this is 40. So 19n plus 1 will be greater than that, isn't it? 19n plus 1 and then 20n plus 1. The first one, if you consider, this one is, it is equal to 19n and less than 19n plus 1. Okay? So this I put a blank over there. It will be in between. And next one, in between 20n and 20 into n plus 1. So this will be included and this is not included. So put a blank over there also. Clear? You have to get the common solution for this, so that both the inequations are satisfied. Inequality 1 and inequality 2. So which part is common? You all can see that this part is common. 20n to 19n plus 1. So x is greater than equal to 20n and less than 19n plus 1. So x must belong to this interval 20n comma 19n plus 1. Now, this interval will be valid if 20n is less than 19n plus 1. Hope you understand. This implies n less than 19. Am I clear? Even if it is equal, then no solution will match. So what we are going to do for several values of n before 19, you are going to solve these intervals. You are going to find number of integers lying in those intervals. So if I write this manner, that solution set is sigma 20n comma 19n plus 1, it will be justified. And n going from where to where? N going from 1 to 18. Because if you take 19, then this is 380 and this one also 380. So it is actually the union. I wanted to write union of these intervals. No, this union runs from n equal to 1 to 18. So you put there, this is going to be 20, n equal to 1. If you take, this is going to be 20 comma 38. And this union, if you put n equal to 2, this is going to be 40, 57. I'm extremely sorry because by mistake I have taken this one 2. It will be less. It is, the solution is going to be less than that. No, you should take care because that is not included. It cannot be included as per the number line shown over there. So this will be 20, 38, 40, 57. Union what? I just write one more. That is 60, comma 76. And finally, where does it go? Up to 18. This is union. If you put 18 over there, then it is 360 and 361. Okay. How many integers lying over there? Number of integers here will be 19. How many integers lying over there? That is going to be 18 because 40 is included. Here how many? 17. And at last we get 1. So number of solutions going to be 19 into 20 by 2. Hope you have understood.